Let us now look at a simple but effective algorithm for classification. So we have a problem of, say, classifying, say, fruits into two classes, say apples and oranges. And we have captured the fruits with the help of, say, two features, say, color and density. Now we have the fruits represented something like this, say this is apple and this is orange. And our problem now is, given a new sample, we want to automatically classify. So we are given a new sample, say a sample which has this feature and this feature measurement, something like this, leading to a sample here. We ask the question, is this apple or orange? I think by looking at the picture, the answer is quite obvious. This fellow will have to have the label of the nearest friend because they are very, very similar. They have very similar color and density, and they are similar, so we say that this is an apple. Similarly, if you had a sample here, the classification is quite straightforward because this is very similar in color and density to orange, the other samples that we had seen in the past, and we say that this is orange. So now, availability of a few samples beforehand is helping us to make the decision on new samples, which we have not seen till now, which we don't know the labels, but we can make the decisions. We can make the predictions. The problem becomes more interesting when, say, we have a sample somewhere here. It is not quite clear whether this should be an apple or an orange. So if you look at the nearest friend here, so the nearest friend in this case is this. This is the closest sample. And we can say that this is an apple. It is not obvious that this classification is correct. Indeed, we don't know the truth, so we have to make the best guess available to us at this moment. So one way where we can improve this algorithm is moving from the nearest neighbors to k nearest neighbors. Say 3 nearest neighbors. Instead of looking at the nearest neighbor, let us look at 3 nearest neighbors. So what are the 3 nearest neighbors to this sample? And if you look at 3 nearest neighbors and make the prediction based on the majority in that 3 nearest neighbors, the labels, it is going to be orange. So we saw the interesting situation here. The nearest neighbor telling us it is apple, and 3 nearest neighbor telling us this is orange. So we ask a question like, is it that this k some magic number that we need to use to get the right prediction? Yes, unfortunately. We don't know what is the right k. And this is a parameter sometimes we have to fiddle with. And there is nothing like predicting always the correct. We may make an error in the prediction. So we need to find a reasonable estimate of k based on our experience, based on some data that we have access to for adjusting or finding the appropriate k. Now there is one very important issue still left out. So one issue is about k, what should be the value of k. The thumb rule is usually it's an odd number, so that majority voting will not lead to a tie-breaking situation. So most practical problems use say 3, 5 or 7 or something like that, not very large k. More technically serious question for us will be, what do we mean by the distance? In this picture, we use Euclidean distance as a distance for choosing the nearest samples. Why should we use Euclidean distance? There are a number of other alternatives with that. We'll see some of them later. So the choice of Euclidean distance is a tricky thing. Maybe we will find a better distance. You will also remember that when we looked at an axis, we never really tried to scale it. For example, assume this is a distance. Is this distance in millimeter or in kilometer? And that changes the distance. So there may be smarter ways of finding the distance which can take care of the axis scaling or which can sometimes take the properties of the samples. With no extra knowledge, we will start with an extremely simple distance measure, that is Euclidean distance, and a simple algorithm that looks at the neighbors and make the prediction, popularly known as k nearest neighbor algorithm.